Thanks to this small device, your electronic gadgets can operate smoothly without interruptions. A capacitor is a tiny device that stores energy and maintains a steady voltage during power fluctuations. Capacitors are made of two metal plates, separated by a dielectric material. Let's examine this circuit to understand how capacitors work and how applying voltage to them stores energy. Initially, the plates of the capacitor are electronically neutral, meaning the positive and negative charges are equal. When voltage is applied to the capacitor, electrons from the top plate are attracted to the positive terminal of the battery, while electrons from the negative terminal of the battery are pushed towards the bottom plate. The dielectric material between the plates prevents electrons from flowing through it. After some time, electrons accumulate at the bottom plate, leaving the top plate positively charged and the bottom plate negatively charged. This creates a potential difference across the plates. This process continues until the potential difference across the capacitor equals the potential difference of the battery. Due to this potential difference, an electric field develops, which is directly proportional to the potential difference and inversely proportional to the distance between the plates. Increasing the potential difference or decreasing the distance between the plates increases the electric field across the plates. The capacitor stores energy in the form of the electric field. Even if the voltage source is removed, the charges across the two plates will remain. Now, let's see how the capacitors are used. We'll connect an LED bulb across the capacitor. When the circuit is turned on, electrons from the bottom plate flow to the top plate, allowing current to flow through the bulb and make it glow. This continues until all the electrons are transferred, and the capacitor becomes electrically neutral, discharging it. The ability of the capacitor to store charge is called capacitance, which is the charge developed across the capacitor per voltage. Capacitance is measured in units such as farads. In practice, smaller units like millifarads, microfarads, and picofarads are commonly used. The capacitance and maximum voltage of the capacitor are typically labelled on the capacitor itself. Let's take a closer look at this circuit to understand how the capacitor operates. In this setup, the capacitor is connected in parallel with the bulb and the power supply. When the circuit is active, the capacitor charges and stores energy. If there are voltage drops, it can supply power temporarily. This helps smooth out interruptions or power fluctuations. Think of it like a water tank. When you close the valve, water flow stops, causing fluctuations in the flow. However, if you first allow the water to flow into a tank, you have a backup supply. When the valve closes due to the fluctuating water flows from the tank for a brief moment until the valve reopens, smoothing out the water flow. Capacitors have various applications. Let's explore some of them. Voltage regulation. Capacitors can stabilize irregular voltage across a device by providing power when there is a voltage drop, similar to our water tank analogy. Flash photography. In flash photography, capacitors store electrical energy and release it quickly to produce a brief, intense burst of light. This helps capture well-lit, high-speed moments in low-light conditions, freezing fast-moving subjects. Motor fans. Capacitors in electric motors, like those in fans, serve two essential roles. Starting capacitors provide an initial power boost, enabling the motor to overcome inertia and start spinning. Running capacitors help maintain a consistent motor speed and improve efficiency during continuous operation. Together, these capacitors ensure reliable motor startup and smooth, energy-efficient performance in devices like fans, enhancing their functionality and lifespan. Capacitors are crucial components in electronics and play a vital role in our daily lives.